it turns out that back in the 40s, when artificial neural networks were invented, 1943, actually that's 3 years before the subroutine was invented. So the subroutine was invented in 1946. This is before the subroutine was invented. So this is artificial neural networks. So this is sort of the kickstart of AI and machine learning. And actually, nothing happens in a vacuum. So prior to the 1940s and the 30s, what was interesting is that it was very exciting to apply mathematics to biological phenomenon. So that was the hot thing in the 30s, was applying, like, who thought, like, wow, you could apply mathematics to biology? This is mind-blowing. That was the 30s. So artificial neural networks and AI basically came out of that from the 30s. So we had artificial neural networks. Now, regular expressions that we use today in Java and in other languages was because a researcher, Stephen Klein, he said, wow, this AI stuff is really cool. I want to experiment with it. So what type, what thing in biology can I experiment with to look for patterns? Like, well, obviously humans deal with text. So maybe I'll deal with text. I'll experiment with text patterns. So he invented regular expressions to experiment with AI. That's where regular expressions come from, because they're looking for patterns. That's the key word. They're looking for patterns, and he chose text, which obviously that was the easy thing because text is easy to work with, right? So that's where regular expressions come from. So again, in the 40s, when all the exciting stuff was happening, is that we have this researcher from MIT, Norbert Wiener, said one of the most interesting aspects of the world is it's made up of patterns, right? And I would say, because I studied astrophysics, I saw the same thing happen in astronomy. So it's the universe, it's not just a world. So this is really cool. This is the basis of what we're doing with generative AI today. It's all about patterns. And this is why it's not just about code generation, and it's not just about ChatGPT generating poems and lyrics. We're talking about something pretty profound. So this is well, so artificial intelligence has been around since then, the 40s, and certainly the famous Dartmouth conference in the 50s. And in the 80s, AI was very, very popular. In the late 80s, I worked for the New York Stock Exchange, and we used AI to try to catch insider traders. And we use all these tools like expert systems and symbolic AI, all the stuff in this gray area. So artificial intelligence is just simulating human intelligence. Of course, you can argue whether humans are intelligent or not, but we won't go there. So that's traditional AI stuff. But back then, when I was at the New York Stock Exchange, we were programming in Prolog. So we wrote a lot of code in Prolog, which is almost impossible to debug. But we're writing code. Now, machine learning is a subset of AI because it's simulating human intelligence. But what it's doing is that you're not writing explicit code. Machine learning is a system that looks at data and derives patterns. Right? Machine learning is a system, it's an AI system that looks at data, and without writing explicit code, it looks at data and determines patterns. That's what machine learning is. It learns patterns from the data. The machine learns patterns from the data, hence the term machine learning. So that's a subset of AI. Now, there's another subset of machine learning called deep learning, because now, it's 2025. We've had cloud computing, we have GPUs, we have advanced networks, we have a lot of cool stuff, right? A lot of computing resources to deal with. So deep learning is it's like machine learning on steroids, right? We have a lot of powerful machines. We have cloud computing. We can fire up the 100 machines in a few seconds. So deep learning is just like, super powerful machine learning. It's again looking at data and deriving patterns. But in practice, you probably won't hear the term deep learning that much. The correct term is deep learning, but everyone says machine learning. I just want you to know that. I mean, but we know, because we're supposed to be the smart people on the planet, it's really deep learning. Now, the two subsets, which in green here. There's predictive and there's generative. Predictive deep learning, generative deep learning, but nobody calls it that. We call it predictive AI and generative AI. But I want you to know this is the formalism, right? There's predictive AI and generative AI. So we're going to talk about generative AI, but I wanted to point out that also predictive AI, right now, most of the money in AI comes from predictive AI, right? Most of the money generated from predictive, most of the money in the AI field comes from predictive AI because it's been around for like a long time. I mean, Amazon, Google have been using predictive AI for at least 15 years. Netflix has been using predictive AI to look for similar movies and shows using predictive AI. Amazon, right? Recommendation systems that we talked about before. Okay, that the big bulk of the money is in predictive AI when you have structured data and you want to find patterns in structured data. Okay, by far and away, that's the big bulk of money. Generative AI is the other one on the left here. Actually, just a little plug for VisRec. So that's the GSR that me and my colleague Zoran for visual recognition in Java. So that was a cool thing to work on. But so generative AI, we're going to focus the rest of the presentation on generative AI. So generative AI is sort of newcomer. So in terms of money generated, it's not as big as predictive, but over time, it will probably surpass predictive AI, maybe 3 years from now. Because there's a lot of cool things you can do, obviously, with generative AI. So this is, I want you to know this diagram because when people use generative AI, they don't understand some of the stuff. And since we're supposed to be the smart people on the planet, I want you to be aware of this. Okay, so where can we apply AI? So I know we talked about code generation, we talked about plugins for an IDE, looking up things, Stack Overflow on steroids. But let's look at the big picture. We can use AI wherever there are patterns. And we're in the early days of generative AI. We are truly in the early days. The transformer architecture was just 2017, right? And ChatGPT is like 2.5 years ago. So we're in the beginning of this long tail thing. So one day I was looking at synonyms, right? Looking at synonyms for patterns, and I looked at all these different words. So you can use generative AI everywhere. All these words imply patterns. So there's a lot of opportunities, and we're just seeing the early opportunities in chatbots and code generation. But we're talking about like it can be applied everywhere, right? I'm saying maybe not tomorrow, but over the next few years, AI is going to start to go into every aspect of what we do on a daily basis, right? But let's talk about, since we're all developers, let's talk about development process. So where are the patterns? So one day let me just draw, what do we do on a daily basis? So there's 4 categories. I hope there's 4 categories, but at least during my caffeine fueled drawing in Google Slides, I did this. So we have ideation, just a fancy word for saying, thinking. We have requirements analysis and prototyping. So you're thinking about like what to build, right? And how to design the project, how to scope out the project. We have over here on the right, we have development, of course, docs, writing docs, creating a UI. There's code generation, only one box. There's only one box here on this page that says code generation. There's unit tests, sprints, demos. We finally get the deployment, right? Track the users, tests, feedback, all that good stuff. Then we have maintenance, everyone's favorite aspect of software development, right? We're tracking issues, tracking bugs, security, all that good stuff. So there's 4 basic categories. In addition to the 4 basic categories of our daily life, we have other stuff. We have to go to meetings. There's those emails and text, writing status reports for your manager, right? You're searching for stuff on your machine or in the cloud or in Google. You're solving problems. These are the things that we do on a daily basis. all this stuff. And it's really funny when you hear about a company that says, well, generative AI look at a code generation. It's going to generate code and that's it. You're done, right? That's all you guys do is just write code. It's like, well, no, actually, we do a little bit more than just write code. There's only one box in this slide that says code generation. And right now, it's the early days. So generative AI is talking about code generation because it's probably the easiest thing out of all these things to show people and get their attention. But there's more than code generation, right? So I think going forward, and certainly if you have some of you out there are very entrepreneurial, take a look at some of these boxes and think, how can I use generative AI to improve prototyping or tech support or integration testing? Or how do I help it search for more information? So the amount of AI that's going to be sprinkled into the entire software development process is going to grow over time. We're just seeing it now, like with code generation, maybe with unit tests too. To some companies that now automatically generate unit tests, searching for information. We're starting to see things that you can put in a whole repo and you can look for things and look for patterns using AI. But there are other aspects of our daily life that AI will encounter. And you have to know about these tools. And if you're, again, if you're entrepreneurial, start a company and then use AI to help with one of these other boxes. So patterns are everywhere, right? It's not just code generation. It's not just, writing funny lyrics to a poem, right? So let's look at neural networks. Now, certainly we're not going to dive in deep, but I want you to know just enough so to understand how this stuff works. Okay. So again, we're not talking about things that were invented yesterday, right? It's a natural language processing, NLP, that came out of the 40s, right? During that really exciting period of AI, early days. Little did they realize it would take like 80 years before this stuff would be used for real. But so that's 1940s and language models, right? We know about large language models, but the notion of language models is from the 1991. So everything was, proceeding normally until 2017. Now, what happened in 2017? So Google came up with a new architecture for machine learning called the transformer architecture. And there was a lot of interesting advances in the architecture and making it faster. But for Java developers, what was interesting is that this paper allowed the training, when you train a model, it allowed training to be parallelizable. It allowed training to be parallelizable. Did I say it right? Parallelizable. That was one of the big advantages of the transformer architecture. Yes, it talked about, words and relation words in one sentence to other sentences, but to do this in parallel, and we know about the benefits of doing things concurrently, right? And even beyond concurrently, in true parallelism, not just virtual parallelism. So after 2017, the world changed. And every single generative AI large language model is based upon this architecture. And Google patented. Google has a patent on transformer architecture. What they do with it, I have no idea, but they patented the transformer architecture. So how does this work? Well, how does the neural network training work? So if you think about a neural network, it's just a large data structure. And data flows, and this is one way of looking at it. So I have these green lines, and that's the probability of a text choosing the next level down. The deeper the green, the more likely a certain text is going to be selected. So it's like, you have like what are those games called in Japan? Pachinko games, like when the ball's bouncing down. So like what's the most likely place for it to go? It goes over here, then it goes over there. So it's following the most likely path. And it's almost like water going down the side of a mountain. Wherever the gradient is, that's the most likely place for that water to go. Is it always the way that the water goes? No, but it's a likely way. So that's sort of like a neural network. It's following the gradient. It's following the most probable paths in a neural network. And the more data you put into this neural network, it strengthens certain paths. So the more data you put through there, the certain paths get strengthened, and some paths are not. So then when you ask for, like, I want a new path through this, it's going to follow the most likely path through the neural network. And once it's taught. So then you have a model. Once you teach that, you have a model. So how many models do you think are available? How many models do you think are available? I'll give you, like, unfortunately, I can't see the chat window. Oh, let's see. I can see your faces. Now I go, where's your chat window? There it is. Okay. So Daryl says hundreds. Anybody else? Joan says 50. Any other guesses? How many language models are available? No other guesses? Okay. As of a few weeks ago, there's 1.3 million. There's so if you go to this link down the bottom here, this Hugging Face link, you'll probably see I bet you it's like 1,000. It's 1,000,035. I bet you it's 1.35 at this point. I mean, if someone can visit that link and see what the actual number is. But so this is a few weeks ago, there's 1.3 million models. I mean, some of the models are older models and they're not used that often, but it's a lot of models, right? That's a lot of, different types of models. And some of the models are more accurate than others. That's wow. Thanks, Stephen. 1.38. And I guess so. The activity of the past few weeks is because of DeepSeek, right? The Chinese open source mixture of experts model set of models. So I'm sure that started a little bit of activity. So 1.38. Wow, that's more than I thought it would be. Thanks, Stephen. So there's a lot of models there, and there's different models for different purposes, right? And there's not just text models there's listed. There's audio models. There's computer vision models. There's models for finance. There's models for medicine. There's very inexpensive models if you want to just use development and you want to test it against the model just because you don't want to spend that much money. There's very cheap models, and then there's very fast, low latency models. There's more accurate, high latency models. So there's a lot of models, and as we go forward, there's going to be even more models, right? Okay, so these are the basics, and I'm sure some of you know about prompts and completions, but let's just talk a little bit about this all-important term called context. Okay, the first thing is that a language model is not really a search tool. And I know that when I see people that don't understand what generative AI is, they'll use it like a search engine. Okay, you have to remember it's a model. And what is a model? A model is a probabilistic notion of something. It's not an exact duplicate. It's a probabilistic beast, right? It's a model. So, but there are some big AI companies that use a search engine. Now, behind the scenes, they're using a search engine and a language model, right? And the language model, once a year or maybe once every 9 months, they train it on general internet text. This is like OpenAI and Anthropic and all those companies. They train it, periodically because it's expensive to train. And I guess it's getting cheaper. I think DeepSeek has taught everybody that, you don't have to spend that much money to train. But my point is that they train it 9 months a year. So it knows about the patterns. It doesn't have the data. It has the patterns. of the data in its model. And then along with the search engine, then it becomes quite powerful. So a lot of these big companies are using a search engine, like Google is like using a search engine along with a language model, a set of language models. So, but don't think of it as a search tool. I think that's where people get into trouble. Don't think of it as a search. It's not a search engine, right? It's really a text pattern recognizer, right? And it's completing text based upon probabilities. You might get a good answer from it if it's trained on information based upon the most likely way for it to go through a neural network. But it's not really a search engine. I think once you make that leap that this isn't really a search engine, but it's being used with a search engine, you sort of like you now cross the chasm. Then now you're starting to understand what it really is. And then you understand when you get unusual answers and why it's not giving you 100% of what you want. Then you understand, oh, that's the way it works. Right? It's a different tool. IT is used to the determinism, right? For decades, we've been used to determinism. This is not the Weather Channel, right? We're not working on probabilities. It was determinism. Now, for the first time, we're dealing with probabilistic output, which is a big shock to a lot of IT shops.